Hello and welcome to, I think it's the fourth iteration of our Code Unboxed event, third iteration. Thank you, Clement. Today we're going to be going through Libjxl. A little bit of a different approach today. Today's session is mainly going to be focusing on fuzzing. With me, I have Clement Gillard. Clement, I know we're jumping ahead here a little bit on the intro, but welcome again. If you wouldn't mind saying a few words.
I'm glad to be here presenting this third approach on how to use TrustInSoft Analyzer on open source projects.
Excellent, thank you. Before we get started, I do want to just go through a few housekeeping items. As with all of our Code Unboxed events, we do follow a 90-day disclosure policy, and that is for any of these Code Unboxed events. If you've been participating and joining them before, you'll know that what we do in these sessions is we use our TrustInSoft analyzer to show how we do an analysis on specific open source code. What we do follow as well is, as I mentioned, a 90-day disclosure policy. So we always do notify the owner or the responsible party for the respective code that we're analyzing of any undefined behaviors or vulnerabilities that we do identify at least 90 days before a Code Unboxed event, so that gives the opportunity to the owner to at least address those or let us know that they don't want us to disclose any vulnerabilities in their code without them having the opportunity to address them. Other housekeeping items, this session is being recorded. We will open it up to questions at the end of the session. So by all means, please do populate the Q&A panel there with any questions. I know Clement might periodically stop and address any questions throughout the session, but by all means, please use the Q&A option to submit any questions, and we'll be happy to address those. And then, as I mentioned, it's going to be made available for on-demand viewing after the session. We generally will post these sessions a day or two after today's live session. So with that, I already went through and did a little bit of an intro on Clement Gillard. So Clement is one of our senior trainers and analysts at TrustInSoft, has a wealth of experience with formal verification and formal methods and testing software. So Clement, welcome again, and thank you for running through this. I know it's going to be an exciting session today. Like I said, a little bit of a different session where you're going to be mainly focusing on fuzzing. With that said, as I've mentioned, today's session is around, we're going to be showing some fuzzing capabilities on Libjxl. If you're not familiar with what Libjxl is, it is used for compression of images. Some of common use cases with regard to web imagery delivery or digital photos or archiving or creating large workflows. In a nutshell, it's focused on image compression. That's what is typically used that Libjxl is typically used for. So with that, a little bit about who TrustInSoft is, if you're not familiar with what we do and our solutions. We effectively, our mission in life is to empower developers to deliver mathematically proven zero defect products. So what exactly does that mean? Well, when you look at our solution, we have an analyzer that we provide to developers, and that analyzer utilizes formal methods. So by using formal methods, we're able to really go deep into the analysis, as well as providing mathematical proof, that the respective software that we have tested is free of any critical bugs. We'll get into that in a little bit more detail, what that means later on. But the other benefit of utilizing formal methods, and specifically the TrustInSoft analyzer, is with some generalized inputs, we can test billions of inputs within a particular piece of code or within a code base. And that saves extensive unit test creation and extensive testing that one has to do, and ultimately results in that mathematical proof that we can provide around the testing. So if you're not familiar with formal methods and you want to understand, well, really what's the driver behind it, when you compare typical static analysis testing, the problem with it is that typical static analysis testing misses a whole bunch of paths that frankly, you might just not have tested. Some common examples, real-world examples, that we've listed here. Heartbleed, a number of years ago, was the result of improper input validation, and it impacted hundreds of thousands of websites. Most recently, I'm sure if you're attending this session, you've heard about the CrowdStrike outage. That was as a result of an invalid memory read. And then a little bit as a result of, I suppose, rockets in space and military, the Ariane flight V88, excuse me, was a result of an integer overflow. So these are all common or undefined behaviors that utilizing something like formal methods, you're able to detect. And that just goes back to in the other illustration here is utilizing formal methods. You could provide mathematical proof that you have indeed evaluated all specific paths, and you ensure that you're providing that mathematical proof across the entire tests, across all of the testing that you're doing. So with that, I think I'm going to hand over to Clement now, who's going to run through and analyze some code. So Clement, back to you.
Thank you, Gavin. So the goal for this session is to show how we can integrate fuzzing, which is a well-known and used way to look at some code and maybe find issues, typically about security, some exploits in it, and how we can combine the power of fuzzing with the powers of TrustInSoft Analyzer. So we are going to focus on 4 goals here. The first one would be that we can find we find that we can find more vulnerabilities than fuzzer and sanitizers alone. They typically miss. I will show some egregious examples in a little while. We can also, with the analyzer, show that the code is correct according to a target platform, whereas fuzzing is typically run on some cloud platform and not on the actual target architecture. We can save resources. So a big point of fuzzing is that it's the machine doing all of the work, and very little time is required for a human to set it up and then look at the results. And so, yeah, if we can also include TrustInSoft Analyzer in that strategy, you can get something similar to the proof that you get with TrustInSoft Analyzer, but with less human involvement. And also, TrustInSoft Analyzer does not come alone. We have many different tools that allow you to go back to the root cause of the problem. And so having the ability to do that with some fuzzed inputs would be great. But first, let's have a recap on fuzzing. So I think my animations don't work. Oh, not in the right order. Okay. So a bit of a recap on what fuzzing is. So we start with our software under test, the software that we want to kind of strengthen. We want to find the issues in that code. First, we're going to write a fuzzing driver. The fuzzing driver will be a little piece of code that will kind of make an adapter between what is required by the fuzzers and what is required by the software we want to test. Typically very short, but we still have to code it. And all of that together, that makes our fuzzing target, right? So the fuzzing target is essentially a self-standing program that can take an input and instrument our software under test. That's it. Now, this fuzzing target, we're going to combine it with a fuzzing engine and typically also with a sanitizer to make a fuzzer. Now, the goal of the fuzzer is to generate new inputs for the fuzzing targets using basically randomly, but also there's some heuristics in how to generate them. And the interesting inputs that are generated are going to be filtered out and sent to a human reviewer. And then the reviewer can use those interesting inputs to figure out whether there is an actual bug and you need to file a bug report, whether there is a potential exploit here and there might be some security issue in the application. Now, interesting inputs, typically that's going to be either some coverage, code coverage, branch coverage. That's going to be some crashes maybe. So if the fuzzer manages to crash the fuzzing target, probably that interests the reviewer. Because we also include the sanitizer, the fuzzer is also going to try to cover the sanitizer. And so we'll try to trip the sanitizer. And so again, if the fuzzer is able to generate an input that makes the code do something that the sanitizer doesn't like, that's something interesting to the reviewer. And there's also many different ways that you can tell a fuzzer some input is interesting. That's going to depend on which fuzzing engine you use. There are multiple ones on the market that have different configuration options. And so the way we're going to interface the analyzer in all of that is that we're going to take the interesting inputs and we're going to run in the analyzer our fuzzing target with those interesting inputs with the goal of maybe finding more issues than what would have already been identified by the fuzzer and the sanitizer alone. And the idea behind that is to not only use that to write more bug reports, but also make some use of the tools that come with TrustInSoft Analyzer, like the root cause investigator, that can be really helpful when you find some very edge case. It might be very important to look at it in the root cause investigator. So, as Gavin introduced, today we're going to focus on Libjxl XL. This is a piece of open source software. You can find it on GitHub. This repository contains a reference implementation for JPEG XL, which is a file format for large images. So using this Libjxl XL, you can encode from and decode to various image formats. So something like regular JPEG to JPEG XL or PNG or GIF or whatever. In this repository, you will also find a different module called JPEGly, which is an implementation by Google of a regular JPEG library. The idea being that it's going to be more optimized, more streamlined than regular JPEG libraries using the same technologies as JPEG XL itself. Something to note, as Gavin introduced, we observe a 90-day period between the moment where we finish our analysis and today when we present the result. In the meantime, it turns out that JPEGly has been moved to a different repository. So when I say that I will talk about both JXL and JPEGly, you have to understand that nowadays in this repository, Libjxl, the JPEGly part is basically not maintained anymore. It's all going to be in a different repository. So yeah, today we will target both the JXL and JPEGly decoders. So the decoders are the pieces of code that take in data and turn it into the image, the abstract image data to then be re-encoded in other formats. So this is most likely to be where our attack surface is going to be. These are the new developments that have probably been less strained by time. And so, yeah, because they accept arbitrary data, they're going to be perfect targets when it comes to fuzzing. In fact, they are so good targets that the project is already been fuzzed by its developers by the initiative of OSS Fuzz. So OSS Fuzz is an initiative by Google where developers, they register their project to be fuzzed. So they provide all of the scripts, all of the configurations that are needed to do the fuzzing on their project. And then Google uses some of their computing power to run the fuzzing and report whatever interesting case, so whatever crash, whatever vulnerability is found privately to the developers. This is a big initiative by Google for the open source community. But for us, that's good news because that means that we don't have to set up the fuzzing ourselves. The fuzzing is already been done. So short of some few technical modifications I had to do, the fuzzing is already pre-made by the original developers of Libjxl XL, so I can directly reuse what they did. So as far as my work goes, I will now show my screen. So an analysis with fuzzing is going to start essentially the same way as a regular analysis for any project. We're going to start with a config. So I wrote here first config.json. This is a regular configuration for the analyzer. So you can see I have some global parameters. Libjxl is in C++, so I have some C++ specific parameters here. I also had to do a little tweaking on the dependency highway, which is used to do vectorization. So that's how Libjxl, so JXL and JPEGly, they are so fast. It's because they make a lot of use of vectorization. But in the analyzer, we do not have support for vectorization. Thankfully, Highway also has a scalar mode, which is essentially no vectorization. So yeah, I have this configuration here that's a bit hidden, but it's essentially just to force Highway into a no vectorization mode. And then I have so my two configurations. So one is going to be a DGXL fuzzer, which is the name of the fuzzer for OSS Fuzz, with the list of files here. And the second one is going to be a JPEGly deck fuzzer, again, the name of the program as made by the original developers, with the list of files. So with that, always with fuzzing, the goal is automation of fuzzing. So typically you will write a script. So thankfully, again, with OSS Fuzz, the OSS Fuzz initiative, the developers have already provided a lot of scripting utilities to perform the fuzzing. So I wrote my own script, fuzz.sh. And so you can see, so there's essentially a couple of parts. So I start with creating the fuzzing corpus. I also run the fuzzer for a few rounds just to make sure that I have more cases than what is already provided in the existing corpus, and then some preparation for the analyzer. I then duplicate all of that for JPEGly because it's going to be very similar how we fuzz each project. So it's just duplicated every time. And then in a loop, I'm going to run TsFuzz. So TsFuzz is a utility inside of the TrustInSoft suite of software that allows you to interface the analyzer with the results of fuzzing. It's essentially just a scheduler that will take the results from the fuzzing and feed them one by one to the analyzer in an orderly fashion. So that's what I've been using here. And then, so yeah, some sorting of the results. And I'm going to run that in a loop. So I'm going to generate some new fuzzing cases and then run TsFuzz and then do that in a loop. So we did that. Once I had set that up, and there was a little bit of trial and error in the beginning, but after a couple of days, I had this script ready. I had my configuration ready. And so we let that script run for a couple of months, a couple of weeks, sorry, almost a month. And so in the end, we had essentially a big fuzzing campaign, a big campaign of analysis with many thousands of analyses. For each of them, we had some UBs that were found, some faults that were found. And so, yeah, only after a couple of weeks, only after all of this work has been done, do we have to bother and check what the analysis have found. And so I have identified here 3 cases that I want to show you. So I'm going to feed them into the analyzer. So this first one is going to be inside of DJXL. So the JXL decoder. Going to take a couple seconds to load. Okay. So now I'm in the root cause investigator. Okay, so let's go to the alarm, and we see here we are in some function visit blend mode, and in that function we are reading some initialized data. Okay, let's go back using the root cause investigator. Let's see how we can make our way back to why we have the issue. Let's understand together why we have the issue. So this pointer here, blend mode, okay, looks like to be a valid pointer, but if I dereference it, I see initialized. Indeed, I can't read initialized data. That's not allowed in C++. So let's focus the call stack and make our way up the call stack up to maybe get an understanding of what happened. So I'm in this visit blend mode function. Let's go to the caller and see what that mode is. So now I'm in the caller. I'm in a method called visit fields on some class called blending info. And apparently the mode parameter is part of this. So the blending info that we are working on. Okay, so for now it's not obvious what went wrong. We are at the very beginning of the method. So let's continue to go up. So visit fields takes us to visit. Okay, this is a visitor pattern. We see we have some virtual class indirection here. But again, we are at the very beginning of the function. So it's unlikely that something has happened up to now. So let's continue to go up. Who called visit, and what made us read some initialized data? And now we are in bundle init. Okay, that's weird. So we are in an initialization function, and in that initialization, we are reading some initialized data. That smells fishy. In fact, we see that the visitor that we're using, the visitor pattern, the class is even called init visitor, right? So it's supposed to init something, and in doing that, it's reading initialized data. Let's go back up again, and now I am in the constructor for that type blending info. Remember blending info? That's the one that contains the mode that was initialized. So while I am constructing blending info, so it's not yet initialized, I am calling bundle init, which is building an init visitor, which ultimately through indirections and indirections and indirections gets to read from the blending info that I am yet to construct. I am constructing it. So this is a big design issue, probably. The way the initialization is set up is probably not in the correct order. The init visitor is looking at fields that it's supposed to be initializing. You're not allowed to look at initialized data. So yeah, here probably a design issue. Here the issue is that initialized data doesn't really exist once you're in the binary. There's always some data. The question is, what is that data? When you're reading a field and you're doing some computation with it, what is that data? What can it affect? So here's the analyzer is telling us, well, it's illegal to do that, but the real consequence might be you might be leaking information. You might have a behavior that depends on what is in the memory, and what is in the memory that's maybe out of your control, maybe in the control of an attacker. So probably you shouldn't be reading initialized data. So that's the first bug. Here, what I would suggest is do a first pass of initialization of the fields before you do bundle init. In fact, this specific bug of initialized field that was then read by the init visitor, it actually occurs 4 times. So I'm only showing it once here, but there's actually 4 places, 4 fields in 2 classes where we have this issue of the bundle init and the init visitor looking at initialized data. So that's really wrong. Okay, let's fix the code on that one. Like I said, put an explicit initialization. And now let's look at our second state. So this is the one where I run again the very same input, but after having fixed the initialization. And I saw another issue even after that. It should take a couple seconds to load. Yeah. So now I am past this bundle init and so on. I'm in a completely different part of the code. And so if I go here, I see, so here I have some pointer arithmetic, and the analyzer is telling me, well, you're doing a computation here, TMP0 minus 8, that is invalid pointer arithmetic. Let's look at TMP0, and indeed TMP0, it's pointing inside of a valid buffer. It's a valid pointer, but it's pointing at offset 2 in that buffer. And I can't do minus 8 on an offset of 2. That's going to take me out of bounds, and that's illegal. So let's look a little bit more at what the code is doing. We are at the initialization of this end minus 8 field, and we are looking at some buffer, apparently, some bytes, yeah, whatever that means. And then to compute, so end minus 8, we go from the start of the data, we do minus 8, and then we add the size. And so we find again the minus 8 here. So yeah, it turns out that if this pointer is not already at an offset of 8 inside of a valid buffer, this computation, the minus 8 computation, is going to be invalid. We have some wishful thinking from the developer here, assuming that the first byte has an offset over 8. Yeah, that doesn't work. The analyzer does not read your comments. So here, yeah, the computation is wrong. Even if the pointer would be back in bound after adding the byte size, it's still invalid because all intermediate values need to be valid. And so here, the operation is wrong. And the assumption actually is wrong. So the developer had the wrong assumptions in mind. That's typically not going to fare well. Here, the compiler could optimize things or assume things about the structure of the byte array that might be wrong because you did this out of bounds read, actually this out of bounds pointer computation. So yeah, you should really fix that. Here, what I would recommend is to do the operation in reverse. First add the size and then go back by 8. This is almost guaranteed to always stay in bounds, except when I did that, it still found some issues. So not in that specific case, but some other cases still tripped that line of code because it turns out that there might not even be 8 bytes to begin with, right? Nothing in the code checks for the fact that there is 8 bytes. And so now it comes back to why do we want n minus 8? Why do we want this pointer to point 8 bytes before the end of our buffer when our buffer might not even have 8 bytes? When our buffer, there is no way that n minus 8 could make sense. So again, here probably, so we know because of the comment that there are some wrong assumptions on the behalf of the developer that wrote this, but also here the consequences could be huge because the existence even of n minus 8 is a complete fabrication, a complete assumption on the actual underlying buffers that might not be true in any case. So here, the code would need to be rewritten to not make use of this n minus 8, or at least check whether that pointer exists and makes sense to exist before trying to compute it. So that's it for for JXL, the JXL part of Libjxl. So we have found 5 issues in the JXL module. We have found 1 additional issue in the JPEG part. So let me load that up. So again, starting, so this time separate analysis driver for JPEG, and so separate set of inputs. We find that we have an issue in this function here, ycbcr to xrgb, whatever that means. And so yeah, at this line, we have invalid pointer arithmetic. Again, we have some pointer computation, and it could be pointing outside of the allowed buffer. So here, if I look at row, indeed, row is a pointer to a valid base, but at the start of a valid base. And so when I do -1, the result is nonsensical. But let's look at the source code. We see that it's not written -1, it's written K alpha. And K alpha, if I look around, actually K alpha is a template parameter. So what happens here is that some template instantiations use -1 for K alpha. And that means that you essentially are writing here, once you do the template instantiation, you are writing row at index -1, which is illegal. We declared that row was an array of K-max component. I guess that's 4. Yeah, 4. So yeah, you can't do index -1 on an array of 4. And in fact, we can find those instantiations just below. So they do that apparently for optimization. They have multiple implementations with different orders. And when they don't have that K alpha, they put a negative value. And in the end, it all works out because the way the code is set up, the compiler will optimize the read away and will optimize K alpha away. And so I actually found that no sanitizer reports this on any optimization level. So any optimization level, either than 0, I tried with Clang, I tried with GCC, modern ones, and I could not get a sanitizer to find this issue unless I actually removed optimizations. Typically, when you're going to do fuzzing or any kind of testing, you're going to do it with optimizations enabled. And so this bug was not found here, was not found by any of these tools. So yeah, here, even though it's going to be removed at any level optimization, that's still relying on the compiler for doing the right thing, and also assuming what the right thing is. Here, the code as it stands performs UB. The compiler can make any assumption based on that UB. And so here, what the compiler does is ultimately remove the invalid read, but you cannot make sure that this is what's going to happen, especially if you ever were going to run the code without optimization. You would get an invalid read here with, again, all of the issues that this might trigger. So in conclusion, go back to the slides. We found 6, is it showing up? 1212, PowerPoint, are you here? Yeah, it's here. So all in all, we found six issues in Libjxl. We find 4 instances of uninitialized memory. So remember this init visitor that ends up visiting what it needs to initialize, but reading from it, and so it's reading uninitialized data. So this is an instance of CWE 457 use of uninitialized variable. Here, the consequences would be that you are able to maybe control the data, control the flow of the program based on what has been executed prior, or you could also exfiltrate data on what has been executed prior. So possibly a security issue. We found 1 instance of invalid pointer arithmetic in JXL. Remember, this was the end -8 pointer. So yeah, even with the wrong order of operation, there might not even be 8 bytes to remove from the end. So completely nonsensical, very wrong assumptions on the behalf of the developers. This is an instance of CWE 823, use of an out-of-range pointer offset. And here the consequence would be a wrongful optimization. The compiler might make an assumption about the code that is wrong, and so make optimizations on the code that might not be the ones that are expected by the developer. And we also found 1 issue in JPEG XL. So this K alpha that was set to -1, but then used as an index in an array. This is an instance of an out of bounds read. And again, even though, as far as I can tell, all modern compilers, they would optimize this away, this is just something that we cannot rely on. This is not an assumption that you can make, especially not in a sensitive context. Here, the code is wrong. And even though the compiler is today doing the right thing on the code. This cannot be said of the future. If you update the code, if you update the compiler, if you change your optimization level, you might get a different binary code that does something that's really different. So you can't rely on that. And so I'm thankful for the analyzer for reporting these kind of issues. So a bit of a recap on TrustInSoft Analyzer. So Gavin introduced some of our key features about exhaustive static analysis, formal verification, and integration capabilities. So today, because we used fuzzing, we only looked at the inputs that the fuzzer gave us. So we didn't really make use of exhaustive static analysis, even though it could be said that with a fuzzer, and especially a modern fuzzer that has very good insights as to how to explore the code, we're not exhaustive, but we can get a lot of different cases. So formal verification, as always with the analyzer. Here, the cases that I showed, we have, because I was so in interpreter mode, I know that there is a direct path from the input that I gave to these issues. It's not an imprecision by the analyzer. We have an actual proof that these issues can occur in the code. And integration capabilities, I've shown a little bit here. We have the capabilities to script all of that. So fuzzers are already a bit designed to work with scripting. And we also have this utility TISFuzz that, again, makes some of the work to integrate fuzzers with the analyzer. And yeah, so in the capabilities, code coverage didn't really show it, but we have essentially the coverage is essentially the same as with some fuzzers. So some modern fuzzers, they can easily get upwards of 80% of coverage. Fault injection, basically what we did here, we asked the fuzzer to find interesting inputs, and it found inputs that triggered some issues in the code. And data and control flow analysis, again, with the analyzer, and especially the root cause investigator, we are able to work our way back to find what were the decisions taken by the code, what was the data in the code at any point, and we were able to do that analysis by hand, but with incredible assistance from the root cause investigator. And that's it for me. Do you have any questions?
I'm checking. I don't see any questions in the Q&A panel, so thank you, Clement. That was a good overview. If you do have questions, we'll wait around here for a few more, maybe 30 odd seconds, and just watch the Q&A panel. If you do want to, just please pop in any questions there and we can address those. If not, here's some contact details to reach out to us. And if you'd like to participate in the next Code Unboxed, we generally run these roughly every 2 months or so. So reach out to us and we'd be more than happy to include you in this. Or if you have any follow-up questions, please do contact us at TrustInSoft. Thank you.